Hi everyone. So thank you very much for coming to the talk. So I know it's like lunchtime and like everybody's kind of hungry. So I promise it's going to be kind of short. I have like only 29 slides, so like 1 minute or so per slide. It should be fine, and everybody is like free to go to lunch. So yeah, let's just quick intro about myself. Other than the farmer thing, I'm a partner and director of cybersecurity services at Blaze Information Security. I do have a background as a penetration tester and security engineer, have been working in this field professionally since 2005, but I have been, let's say, an enthusiast of computer security before it was called cybersecurity, so since around 1995. And I'm here to talk about a bit about GraphQL. So a brief agenda here is what GraphQL is, what are some security considerations. Of course, there's like plenty of them, and unfortunately, we won't have enough time to cover all bases here, but at least to dabble and talk about some of these issues, and finally conclude the talk. But first of all, actually, what's GraphQL? So can you please raise your hand who has seen GraphQL in any of your testing activities, or if you have heard of this technology before? Cool. Well, there's actually not so many people, which is kind of common because even though GraphQL has been around since, I think, 2012 was when it was first created by Facebook, but only in 2015 it became kind of an open sourced, and yet not that many people are using it, which means that there is still a lot of, say, security attack surface that's not really covered, and some of these considerations. And this is one of the reasons why I thought that it would be a good idea to at least bring some awareness to this topic. But yeah, for those of you who don't know what GraphQL is, it's a query language for APIs, again, like developed by Facebook. The idea is to be an alternative to REST. And with GraphQL, so if you remember your computer science school, it's literally a graph. So it means that the queries and so on, they can traverse the graph and objects, fields, and then fetching all this correlated data that it needs. The main advantage, at least from my research on GraphQL, is the fact that GraphQL is just like a lot faster than REST, in the sense that there is far less network requests going on in order to fetch the data that you want. And then again, it brings exactly the data you want, and you know how the data should look like and how the response of this data will be as well. So nothing more than what you actually need. And they have these things called query mutations. We're going to introduce this down the line. And they are wrapped around like JSON. So it's kind of somewhat familiar. It's something that many of you have seen already. So still like here in the quick overview. So this is like a kind of a comparison side by side of GraphQL and the REST API. So on REST API, let's say the client wants to fetch this data about players, teams, and matches. So it's probably going to send, say, a GET request to like /API/v1/players/ and then the ID, and then grab this information. And then if needs the same something with teams, because then again, maybe this data is correlated, but then have to send another network request for another endpoint called teams. And then another one for /API/v1/matches and so on. So this is kind of considered expensive from a network perspective. Plenty of requests going on just to get what you actually want. And in the case of GraphQL here, you have a client, and you wrap this kind of, it looks a bit weird query, but then you get used to the syntax, and you send a chorus, and then the GraphQL API server will just reply to you what you actually wanted, and in only one request. So this saves, like these network costs and latency, and so on. And then this means that we also should probably introduce a bit of the jargon that's related to GraphQL. The first one being schema. So schema, it's basically the shape of the data. So that it describes, the relationships, fields, and so on. So if you remember from your computer science classes as well, object-oriented languages, you can maybe draw a parallel here that, when you have, I think it's a class, that you have the attributes, and then the methods, and so on. So you kind of describe, the shape of how the class actually should look like, and then you instantiate it, it becomes an object, and so on. So think of a schema, like, again, not necessarily the very same thing, but if you want to draw a parallel to something that you're already familiar with, that could be like a class in this sense. And then a query, again, if you want to draw a parallel to REST, a query is like an operation used to read and fetch data. And a mutation, it's for like crude operations, so to edit, to update, and to delete something or to create some sort of data. Let's see how a schema actually looks like. So this was actually taken from the GraphQL. Unfortunately, my laser is actually not working. But yeah, it would just be easier to point. But it was taken from the GraphQL like original documentation. So we're defining here the schema is like a book. So a book has a title, in this case a scalar, also like a string. A book has an author. In this case here, another type, like so called author. So you'll see there is like a book and then the author, and there is a relationship already. And the author being defined here is a string, and authors have books. So an author may just a one-hit wonder, just wrote one book, or maybe is a prolific author that keeps writing a book every year. Of course, you could like further elaborate that by saying like maybe a book has a publishing date, has a number of pages, and a couple of other things. But for sake of simplicity, what we have here is that, like have a book, author, the title of the book, and then these relationships, as we're going to see here in the next one. So if you see this guy here, Thomas Piketty, he is like an author, and he is connected to, say, like different books. So he's a co-author in The Capital and the author of Economics of Inequality. Again, this is all from the GraphQL official documentation. It's not that I'm necessarily enthusiastic about this kind of books. But it's just like for the sake of illustration. So if you see here, this is like literally a graph, just like your computer science classes. And this means that all this concept of nodes and edges and graphs being traversed and so on, they still apply here. But the way they're done, instead of, say, if I used to call it in C, all these things, with pointers and so on, you traverse this with queries. And what a query is. In GraphQL, it's, again, as we said like a couple of slides back, it's a way to fetch data from the backend. They can be simple or nested, so can have like a query inside another query kind of thing. It's a bit weird, but it can actually happen. And think of it as a GET request. It's just like a different syntax to have like your own kind of GET. I hope you can actually see here. I wanted to actually show this with like online and so on, but I'm not sure if the internet would be good enough. But we have here like Rick and Morty API. It literally exists, like rickandmorty.com, api.com/GraphQL. It is like a good playground for messing around, playing with GraphQL, and kind of dipping your feet in it. And we have here this query called character. Character has like a field and has an argument. And I say that I want character with ID 1. I want to fetch the name, the status, episodes. So then it's like kind of nested as well. And I want to know all the episodes that this character was participating in, the name and the air date of it. And then on the other side, you're going to get that character number 1 is like Rick Sanchez, still alive, and then all the episodes that this character they have like participated in the show. So if you see here, sure. Um, yeah, well, I think my laser is busted anyway, but I can just like go ahead with with the rest of the talk. But it turns out that if you see here, there's a difference in syntax, even though it's kind of under the hood, this whole thing is like JSON, but there's a difference of syntax, and it's just a matter of actually, well, getting familiar with it. Next one is going to mutation. So a mutation, again, is like a query, but the whole purpose is to actually write, edit, modify data in the back end. Also can be simple, can be nested. And if you're familiar with REST, think of it as a put, a post, delete, or patch kind of like operations. And again here, we have like a simple mutation on this left side, and the mutation says DeletePaste. So like this whole thing here that I have is like also not the Rick and Morty API anymore, but this is something else. This is like kind of like a paste bin kind of sample written in GraphQL. And I'm just asking here, like, please delete paste from ID 1, return to me the result of the operation, and then on the right side, I will get the paste was deleted with true. So if you see, you just give exactly what you want, and you know exactly what you're going to get in terms of, because you actually ask, like, please give me this type of response from that, and you're going to get it back. So now let's just, now that we have like a very, very brief introduction about this whole thing, let's talk about some initial considerations in security. So approaching security testing for GraphQL is that, at least in my opinion, from an exploitation or like point of view, the very same bug classes, they still exist. So if you have had any sort of training, or if you have read anything about application security before, you will see some of these vulnerabilities. Like, you will be familiar with terms like OWASP top 10, SQL injection, cross-site request forgery, server-side request forgery, and so on. Absolutely all of these are still present in GraphQL, in the sense that GraphQL is usually kind of some sort of proxy between the client and some backend database, or even other like backend REST APIs. Oh, that's good. Thank you. So there is not much of a difference. Oh, good. It works. Thank you. So vulnerability-wise, it's kind of really the same thing. In my opinion, is that at least when learning this whole thing, the main challenge was actually learning the syntax, learn some of the tooling, and the way how to actually interact with the endpoint. And common security issues that we have here, kind of introspection is kind of one of them. I mean, we're going to see it later. Even though, particularly, I don't think introspection is an issue per se. It's a functionality of the whole language is actually needed. But some people say that this discloses too much information for a potential attacker, which is true. But then again, without the schema, you're not really able to do anything, like or actually test or pen test GraphQL. Access control issues, this is a plague in GraphQL, and we're going to see why. But basically, the security model of GraphQL is super lightweight, in the sense that GraphQL is just here, this is the technology, and then anything security related, entirely up to you developers to implement. And this, of course, is like a landmine it's like problematic, because developers will not either implement this or will implement it correctly because there is no proper guidance on it, and so on. Cross-site request forgery. So this is a very old issue that plagued web applications, like say 15 years ago. It was kind of mitigated or eradicated after, especially like with a couple of things, but also like kind of REST kind of more or less killed it, and it made a surprising comeback with GraphQL. GraphQL also has a concept of batching, we're going to see later. And there is this so-called batching attacks that we're going to describe what they actually are. Then I have service and resource exhaustion. So this is mainly kind of sending queries that are like nested like in big loops or and so on until the consumes a lot of resources from your GraphQL server, and it just dies because of that. And improper sanitization of input, which is still the same story as it used to be, from the 70s, that nobody was really expecting that particular malicious input, and then in the resolvers of the GraphQL, the developers just didn't implement that correctly. And we're gonna be talking about a few of them here. Unfortunately, not all of them, but just going back here. So I think access controls is actually the main problem, at least in my opinion, or in my experience with like performing penetration testing of GraphQL APIs. This is the one that you see all the time. Let's speak about introspection. So GraphQL is introspective, so basically it reviews its own schema. All you have to do is to ask for it. We're going to see later in the next slides, there is this huge query. I mean, you don't have to memorize that. This is, I think, even most of GraphQL clients, they already have this query there. And then you can just send all this query to the GraphQL server, and it just reveals the whole schema. So it's like asking it for its own documentation. So if you're familiar with REST, again, just to draw a parallel, it's like asking the API for, hey, please send me your Swagger, or send me the Postman collections. So please teach me how I can interact with you. And then, as we can see here, we have on the left side an introspection query, and on the right side we have the result. And the result is like huge. Like it has the schema, the query types, the fields, what arguments each kind of things expect, and so on. But it's, I would not say it's JSON, kind of like looks a bit like it, has at least some of the symbols, but it's impossible to read. Basically, as a human, you're not going to be able to get, I mean, you can, but it's just so time-consuming and so error-prone, it's just not worth it. And depending on the schema, so for example, GitHub has a GraphQL API. The schema is like, I don't know, 200 kilobytes or something. It's like huge. Nobody's going through each and every one of them. And because of that, there is a tool. It's called GraphQL Voyager. And GraphQL Voyager, it describes all these relationships. Again, this is a graph. So we have all the queries, how they interact with each other, what types and of each thing actually is expecting, what are the arguments, how you call them, what kind of results it will bring it back, and so on. And GraphQL Voyager, so essentially you send the introspection query, get the schema back, place in there, and this tool is super useful. You can just go there, you can see all the queries, mutations, and you can see it's basically how to interact, how to create your own queries, your own mutations, and so on, to interact with the GraphQL server. It's like super handy, and frankly, without it, it's like so time-consuming and so error-prone, and unlikely for you to actually test the GraphQL as it should. And another thing is, very often you're testing, like you're performing say penetration testing for like a web application that use like GraphQL under the hood, and then you see just a few things being requested, and just a few queries are there, just like a few mutations are there. But then when you get the whole schema and then you put there, sometimes you're going to see functions, or, I mean, like, not functions, but the terminology is different, but a few other things that you can call, if you know how to call it, that the application itself is not really doing. So sometimes people forgot debug, some functions that are for debugging, some functions that let's say, delete database or something, that is just going to be there. Of course, it's not going to be called by the application itself. But then it's super useful to use GraphQL Voyager to fully inspect the whole schema and see things that potentially the application is not being called in the application, but it's there for you to call. All it needs for actually knowing how to call it. And that's what I wanted to talk about. Like this comes from the GraphQL official documentation. It says that authorization, so delegate authorization logic to the business layer logic, period. That's it. There is no guidance on how to properly do this, how to properly achieve that. And because there is no guidance, there is very few documentation how to achieve this in a satisfactory and proper way, that developers keep shooting themselves in the foot all the time when it comes to enforcement of access controls with GraphQL. So I probably forgot to actually talk about like what resolvers are, but essentially, when you send a query or like a mutation or something, and then there will be a resolver kind of associated to it, and then a resolver will perform a certain action, say, for example, fetch some data from database after this actually happened, or make the actual database update, and so on. And then the resolvers are this business logic layer, more or less, at least my understanding, that you should delegate authorization logic to. But then again, how to do it, or how to do it like in a way that should be kind of proper for GraphQL. There is some documentation around, but scattered around, but the official documentation doesn't really give you any sort of guidance on that. And then ACL, so access control related flaws are like rampant, really, when it comes to GraphQL. Like this is like a super simple example here. Again, back to this paste bin thing. Let's say that we have public pastes and private pastes. And private paste, of course, is supposed to be private just for you and the person who has a link to see it. And the public ones, they're going to be there like a display for everyone. So let's say I'm trying to make a query called getPastes. And the query says, well, getPaste, the paste ID number 10. I want the title, the content, and whether it's public or not. And then it will come back the response that, yeah, this is the ID, like just like the one I actually asked it for, the name of the title, the content of the paste bin kind of thing from there. It's public true, fine. But you know, what if you just change from 1 to 15 or from 1 to 1 or 0? Or maybe it could have been, say, a UID instead of like a numeric to make it like slightly harder. So let's say if we change it to 1, and then we are starting to see some pastes that are not public anymore, so like some private ones. So it means that there is just no enforcement of access control when it comes to resolving or fetching these pastes. And you may think that, okay, this is like super lame and this is like super easy. Yes, it's true. And really, like over half of GraphQL apps that at least I have seen in my life when it comes to penetration testing, these type of, let's say, stupid bugs, they're always there. Sometimes the ID is not sequential. It's not super easy like that. Sometimes it's UID, but there is always like, you can always figure out, I would not say not to predict a UID, but figure out a way to get or fetch the UID for a given user, for example, in a different way, like in the application if you explore it long enough. But especially when it comes to UID, like many developers, they feel empowered that, okay, nobody can predict this. This is too random and so on. But there is always a way to figure out that, you know, say that particular user it has that particular UID, and then you combine these things together, and then you can say, execute an action on behalf of the user, say like changing password or deleting the user from database and so on. And every time, again, like half the time I see GraphQL, there is some sort of access control issues like that. We have another concept called batching. So it supports query batching. So basically, you stack up a bunch of requests in only one query or only one mutation, for example. And this is super useful to reduce, again, like reduce latency, reduce like the network costs. But there is also like another thing is that a lot of protections that APIs and like web application firewalls and things like that have related to rate limiting. This just bypasses all these protections. So, for example, if I'm trying to brute force a login and password, and you're going to be sending like over REST, like one connection each time. Okay, let's not do login and password. Let's do another example. Let's do with, let's say I'm logging in, and then I get like an SMS code to, a 4-digit code. And then you keep sending brute forcing from 000 to 9999. So 10,000 possibilities. And you just keep sending one request after the other. And eventually there will be some web application firewall or something, in Amazon or something like in Cloudflare that will say like, okay, this is dodgy, there is something going on here, this is an attack, and it will just like block you. But then when it comes to GraphQL, you can actually batch all of this, like from 000 to 999 in one single request. So there is absolutely no way that Cloudflare or anything else, if it doesn't know the context of the application, this is like GraphQL and so on, it's just one request instead of like 10,000. 10,000, yeah, there was something dodgy. It's just one now. So unless protections and mitigations actually evolve to tackle these new vectors, you can just like potentially something that was protected before is not now protected, because you can just like, in one single request you can brute force all these 10,000 potential pins. And we have like an example here of batching the requests. So there's a mutation like login, password, like login, username, operator, password, and just a bunch of them in only one single request. And if you see on the right side, 5 of them were incorrect, and 1 of them actually worked. And then there you go. Here you have your access token, your refresh token, and so on. But this would have costed the attacker at least 6 requests before, and now with only 1, that was actually possible to do that. But then again, this means that relying on the older protections of things like rate limiting and so on, if you don't really put this into the logic of the GraphQL, into the resolvers and so on, that's another problem with it. It means that these attacks will actually just keep happening or be potentialized. And just a final remarks, conclusion here, is that, in my opinion, from a security testing perspective, REST versus GraphQL, it's pretty much the same thing. It's a matter of knowing how to use the right tools, understanding a few nuances of the technology, learning the syntax, and learning how to interface with it. Many of these vulnerability classes, they still exist in the same shape and form. A lot of security testing is actually overlooking GraphQL. Maybe even QA testing, when people say like, kind of, oh, I still don't know much about this technology, and kind of just scratching the surface, but there is far more to actually see there. And truth to be told is that application penetration testing, at least, it's nothing but glorified QA, in the sense that a lot of people that do like penetration testing, they like to pretend they're hackers and hoodies and Mr. Robot and all that shit. The truth is, like, a lot of what we do is very similar to what you guys do. So don't be intimidated if you actually have interest in getting to this area. Don't be intimidated in actually learning a bit more, like getting a bit familiar with the tools and so on. Some of the best application security people, I mean, again, there is application security, there's like red teaming, there's like so many things in this area, and I agree, there is a lot of black magic, but when it comes to application security, the bar to get in is not that high. It doesn't really take a genius to do that. And some of the best people that I have worked with in application security were actually people that had a background in QA. they were like by far like the most disciplined, and they knew how to really do it. Because again, this is like testing. A lot of what we do is testing. We just kind of like to pretend that it takes a genius to do it. It's bullshit, really. And I think that's all that I had for today. As I said, I promised it would be quick. So we still have like another 10 minutes left. So feel free to ask your questions. Thank you,
Julio. So, do we have any question from the audience? Let me move here so I can see anything. Okay, seems people are hungry already.
Yes, looks like it.
Oh, okay, there is one hand in the air. On my way.
So hi, I have a question. If we are thinking about security, is better for developers to not join many queries in one?
It's completely fine to do it. Like, I mean, it's actually the whole purpose of also like GraphQL. So like you're actually extracting the most out of the technology. But then if this is actually being used, if there is any sort of, let's say, if there is some sort of security decision or anything that can impact security there, if when you look into, like, for example, this thing, like it's checking if a PIN number is going to happen, like it's going to be like approved or not, it's important for the back-end logic to actually understand that and then do whatever mitigation is possible. But I would not say, oh, discouraging using batching. Like, no, not at all. This is actually the whole technology was built also for that. But then to just understand whatever security implications may exist, and then have whatever countermeasures in the code. Because, for example, all rate limiting and all this like WAFs and stuff, like application firewalls and things like that, will not really take care of it.
Okay, thanks. Anyone else? Okay, so thanks, Julio, again. Great topics presented.